Kindly seated, everyone. The theme of the session is Substance, Form and Interaction in Buddhist Philosophy and Quantum Physics. The chairperson for this session is Professor Madhumita Chattopadhyay. Professor Chattopadhyay teaches philosophy at Jadavpur University. She's also the coordinator of the Center for Buddhist Studies, Jadavpur University. She's been well trained in both Western and Indian philosophical traditions. After her PhD, she shifted her research area from Western logic to Buddhism. She's authored 4 books, including What to Do with the Liar, Walking Along the Path of Buddhist Epistemology, Ratnakirti on Apoho, Philosophical Thoughts of Nagarjuna. She's also been awarded several prestigious international fellowships like Fulbright Visiting Fellow, Japan Society for the Promotion of Science Long-Term Invitation Fellowship, Bukkyo Dendo Kyokai Fellowship, and Charles Wallace, among others. The other speakers for this session are Dr. Prasanna Roy, Dr. Atul Kumar, and Ms. Pooja Dabral. I request all the speakers to kindly come up to the podium, to the stage, please. Thank you, Honorable Chair. I request Professor Madhumita Chattopadhyay to please proceed with the chair. Professor.
Good afternoon. Thank you. Good afternoon, everybody. After the tea break, we are assembled here to listen to the session 6 of this interesting conference. The theme of this session is Substance, Form and Interaction in Buddhist Philosophy and Quantum Physics. I have with me as paper presenter 3 very eminent persons. I don't know whether the third one is coming. The topic of this session is Substance, Form and Interaction in Buddhist Philosophy and Quantum Physics, and the eminent personalities who will be presenting their papers are Dr. Prasanna Roy, Dr. Atul Kumar, and Dr. Ms. Pooja Dabral. Dr. Prasanna Roy is Professor Computational Neuroscience and Neuroimaging Laboratory, School of the Biomedical Engineering, IIT BHU, Varanasi. He has been a visiting scholar at Institute of Psychiatry, King's College, London, UK, and research scientist at University of Connecticut, USA. Dr. Roy's research has been acknowledged by the Tata Innovation Fellowship of Department of Biotechnology, Government of India. Professor Roy is a fellow of the National Academy of Medical Sciences, the Indian National Academy of Engineering, and the National Academy of Sciences. It is very prestigious to be a fellow of 3 different academies, one of medical science, one of engineering, and one of sciences. So we should give a great applaud to Dr. Roy, and we are eagerly waiting for his presentation.
Just take this for a moment.
Yes.
Yeah. So I thank the organizers,
for welcoming me back here. And last year Dr. Reverend Damdul was there, and I here will show a little bit, end with the work that we have done last year. So it's also a progress report. And I come from National Brain Research Center, which is a university under DBT, and every year we have this progress report. Okay, every year you're assessed. So I have kept that, after moving to BHU, I've kept that tradition in my lab, and I subject myself also to it, and I also tell you the progress that I've done. Our lab has done last year, so I have both labs in National Brain Research Center, where you were in Gurgaon. My lab is still there, and also the one in BHU. Yeah. So the program is themes, science, form and interaction in Buddhist philosophy and quantum physics. So I'll add in that in Buddhist philosophy, quantum physics and neuroscience. Okay, so this is, we can start here, please. The second slide. Okay. And I've requested Reverend Damdul, if one of the years we could host one conference, Tibetan House Conference, particularly in Tibetan pharmacopoeia, okay, in which we have a school in Benares Hindu University and the Central Institute of Tibetan Studies. And unless we do something, all these herbs, they will actually gradually become extinct. Some are being done, but we need to have a pharmacopoeia. And we can, this is, I would like to place it to the house, submit a project to the Minister of Ayush and get the things going. Anyway, now I come to, yeah. So, substance, form and interaction in mental percepts. So the first, the subtitle was in the abstract, ventral, dorsal and oblique information streams in the human brain. But I changed it for this audience, to make it, otherwise everybody will be frightened. I'm a non-neuroscientist. Okay, so upper, lower and oblique information streams in the human brain. Okay, so, yeah. So the issues, yeah. So I'll finish in that 15 minutes. I've already spent 5 minutes of my time. So 10 minutes I'll rush in, and whatever question answers you have. Okay. So, Buddhist. So last year I presented how you can use this Rorschach test for grading the alteration of attention and its corroboration with Buddhist stages. Okay, so here I have changed because I have been told to fit with this as a theme. So here we will work about first of all, the forms of mental percepts, the substance of mental percepts. This is in the subtitle, and then the interaction between them. Okay. What are the neural correlates? Okay. So one of the things that we are doing in BHU is we were working with linguists, philosophers, and then brain images to see whether there are neural correlates. If you have neural correlates, then it is one of the, you find that people are excited, at least some circuits are there, or some some signatures, maybe however small it could be attributable. Okay. So now we come to so psychodynamic interpretation process. So let us look at this. When you see something, the problem is how do you interpret it? Okay. And one of the big things that we have done, one of the big things that people have been doing it is using initially Rorschach. But gradually, with the advent of these computer programs, you can develop different type of ambiguous stimuli. So one of the things that we develop is a PhD student had developed it, is actually developing ambiguous figures. Okay. And you have seen some, so whether it is a cat or a dog, or is it a vase, half filled vase or full filled vase, or or one of the figures that you have seen probably is whether it is a young maid or an old woman. Okay, how does the gestalt shift? So here we did so this is the thing that we developed. This is an amorphous pattern test, and this, let us see, when you present this, what are the stages and how does the mental processing comes up in the person. Okay, so first of all, so we put the person in the fMRI scanner and give this unstructured test, and let us see how this subject verbally interprets this. So we find that there are two-step interpretation. First, she probes the meaning of the pattern, that is its substance, and does not hone and does not immediately give the word that we told her. When she has to give a response, what it means. She says it's a moving stuff, and then she says that concretely focuses and say it appears to be a fish. Okay, and this is the form of it. So here we try to find out what the neural networks of both phases. First of all is the verbalizing phase, and this is the task positive network where it is synchronous to going and forming developing the form. And but before that you have the task negative network, which is not synchronous to the task of telling what that object is actually, but honing on what would be the object, and it is the non-synchronous which is non-synchronous to the task of telling. So first this happens, task negative network, then the task positive network is focused on to. Okay, so these are the things, roughly the same things explained universal. Last people do this, everybody, all fMRI people do this, so I am not going into the detail of it. So here you get the here you get the first of all the stimulus, then she hones on task negative network, then the verbal response comes, it is the task positive network, and then there are techniques how you do this. Is first of all fMRI data analysis, extraction of the independent components. So these are circuits of the brain which have different frequencies which are independent of each other, and they will do separate processes. Then extraction from the functional MRI activity, the neural activity. Then dynamic causal modeling. So so this node, does it influence this node, or this node influences this node? Which way, or is it bidirectional? And then from that you get the connection matrix between the nodes, and then the weightage of the arrows. How thick is the arrows? How much weight would you give to the nodes? Okay, how much they interact. So this is the principle and by which all MRI signals are analyzed, and let us see what came out in our way. Okay, so when you do that, that means the task positive network, the person concretely states the pattern that is form of the object. This is what this is what emerges. Okay. So these are the top brain slices. As you go down, you go to the lowest one, that means the cerebellum, two cerebellum you could see. So here it is the lower half of the brain that is excited. Okay. Then what are the networks? Basically the lower half of the brain, basically from occipital probe, where she sees the visual stimulus first, then to the temporal lobe, and then to the frontal lobe. Okay, so this is and there is anatomically it is known, this will be the part of the inferior longitudinal bundle. Okay, here is ventricles with the cerebrospinal fluid, and we try to put it in formalism of the information processing streams. So this would correspond to the ventral stream, the lower one. Then we go to the other one, that means the task negative word. The person this happens before the this happens before the person gives the form. Okay, the direct identification. Here she takes a few seconds to probe on. Okay, so it is moving moving substance or moving pattern, and only later she will tell it is a fish. Okay. So here what we got is, so here if you see they use blade slices, these slices are on top, and this is the activation that we got. So this is the upper segment activation, this is also the independent component, and then we did the dynamic causal modeling which activates what, and this is the superior long the areas that are activated, and the linkage between them is to the other one. Earlier one we had the inferior bundle, and this is the superior longitudinal bundle, and this we can correlate it with the dorsal stem. Okay. So once this is done, now is the how does these two interact with each other. Okay. So stages of perception. First is a percept, a substance of the percept, upper stream information. When you give to the subject, she initially looks at it and says, this corresponds to the 2.5 dimensional primal sketch, if you have the stages of perception. Okay. So here the subject says it is moving. I am still to see what she doesn't give a concrete answer. She says it's a moving object, maybe a fire, maybe a bird, this, and finally she says it's a moving fish. Okay, so that corresponds to the second stage of the percept, the upper and lower stream of information. And how does this interaction happen? How does the first stage affect the second stage? So then what we did, we went to the other components. Okay, so this is the other independent component. It differs in frequency. So basically the first component initially at 8 Hertz. This is not this is just an explanatory figure. It's not derived from the other words. And then the second component would be oscillating at a different frequencies, and that would be gives more amount of linkage between the two. Okay. So here if you see the second independent component, so to see here, there are both activation in the, so this is the top of the brain, so slices are here. This is the bottom of the brain, slices are here. So here you can see top, you have the slices here. Then here this corresponds to the middle slice, and this is the lower slice. So here what you see, it's nice. So this arrangement, this would be, you need vertical oblique neural bundle in this upright position to do this interaction. Is there such a bundle? Do you have neural correlates of it? Okay. And this is the bundle that fMRI interaction shows us, vertical oblique bundles. Okay. However, standard publications show you only radial, horizontal or radial fibers. The horizontal fibers are the association fibers, and radial will be projection fibers. Okay, but nothing typically vertical. Okay, so we wanted to see this, explore this problem a little further. Okay, then what we do? Okay, so we went to the work. People typically use migrating viruses to trace tracks. In lower animals, they'll put a virus, do histological study on it, and see how it moves. Okay, so here in humans you can't do that, but there's such a virus, migrating cells. It is tumor cells. You take up tumor, you take glioma tissue, and watch how it moves around in a glioma patient. Okay, so this is what we did. We wanted to show that there are tracks for that interaction stuff. Okay, vertical tracks. So glioma tumor patients, normal volunteer state, and this is how the glioma goes vertically. And then we did a diffusion tractography to see whether there are tracks in. Okay. So this is what came. Yeah. So as a tumor grows, so we need to show that there are tracks. Okay. Vertical or oblique tracks instead of the horizontal tracks. So we did a tractography and found the pattern of it. So these are the pattern of the brain, the portion of the brain around it. And so you can see the perpendicular tracks. the vertical oblique tracts here. And then if you do the microscopic study with this staining, okay, and this is, you can see the nerve fibers arranged parallel at right angles. And this is what we have just published, Journal of Neuro-Oncology. So here we did this tracts alone, and also surprisingly we also did it on corpus callosum. Everybody knows that corpus callosum is the joints, straight wires joining two hemispheres. But you also find tracts at perpendicular to it, and across the brain these three-dimensional tracts using this glamour cells. And the whole technique is available in this. It's just come out in the Journal of Neuro-Oncology. Okay. So even in corpus callosum and elsewhere, this is of course elsewhere, and also in corpus callosum we have similar architecture. So there are vertical tracts. Yeah. So what we can do, we can posit that processing of the substance of processing of the substance of mental percepts, superior longitudinal bundle, processing of the form of the mental percepts, inferior longitudinal bundle, and then we did both tractography and histological analysis, interaction between them, the posterior bundle. Thus, each of the three perceptual operations has three distinct neural pathways. So it's of course some preliminary study. We need to do more study on this and some more. So eight people both. You're seeing not much, so we need to replicate it in more subjects to see whether this three-dimensional new tracks that we're getting from glaucoma patients, and naturally the people who supported us are the Government of India, Department of Electronics, it's now Ministry, National Knowledge Network. So we did part of the work in Benares, part in National Brain Research Center. So consonant we had to do work on both scanners, and you can do real-time scanning now using the National Knowledge Network that has been put up by the Government of India, connecting all institutions. Part of our research is funded by them, and then Department of Biotechnology, Government of India. Fine. So this is it.
We must thank Professor Roy for his finishing his illuminating speech within the time schedule. He has explained with different slides of MRI reports and diagrams how the form of mental percepts and the substance of mental percepts interact to give rise to the perception of an object as so and so, as a fish as moving, or as something as colored, and so on. And this he explained from a neuroscience standpoint. He also explained through different diagrams and through his reports, slides of MRI reports, how the different stages and the different components are involved in the process. And ultimately, he showed how all these are related with the superior, inferior, and vertical portion of our brain structure. So we must, with these words, I request all of you to give a big clap to Professor Roy.
So hope next year I will be able to put myself as a student and show you more.
Our next speaker is Dr. Atul Kumar. He is currently working as an associate professor in the Department of Chemistry at Indian Institute of Technology, Jodhpur. He joined the institute as a faculty member of Center for System Science in March 2012. He completed his PhD from IIT Madras in May 2010 with the thesis entitled Quantum Entanglement and Information Processing. His research interests include foundations of quantum theory, classical and quantum correlations, multi-qubit entanglement, and non-locality. I ask Dr. Ratul to present his paper.
So I thank the chair for the kind introduction. And before I start, I just want to tell you that till today morning, I was under the impression that I'm going first for the talk, because the document that was circulated to us over the email, it said that I'm going first. And then I looked into the booklet, and booklet said that I'm going second. So it was like the state of me going first or second got entangled with which document is correct, the one that was communicated to me over email or this booklet. And finally, when she told that no, you are going second, my state was fixed. So she actually behaved like nature to me and forced me to take a stand, right? And then my state is fixed. So that's entanglement and superposition. And thank you. And I would like to thank the organizers for inviting me to address this August gathering. And the title of my talk today is Quantum Physics, Substance, Form, and Interaction. So when we talk about substance and form, I'll borrow the Aristotle hypothesis, where he said, okay, thank you. Where he said that a system can be seen in terms of substance and a form, where the substance could be its mass and energy, and form could be its physical state. Say, for example, if you're having a paper, then the paper can constitute its, it can be termed as a substance, and its form could be the text written on it. And this example I'm quoting from a book that is called Quantum Chance by Jisin. So the other examples which were there was like an electron. So an electron, the substance could be its mass and energy, and form can be its potential position and velocities. Similarly, for a photon, you can think about its energy as the substance and its polarization as the form. When we talk about interaction, it's the dynamical equation in quantum physics that we use, that is Schrodinger equation, where the Hamiltonian, the interacting Hamiltonian can be used to look into the dynamics of the system, so that the wave function evolves and then gives you the time dependence of how the things are dynamically changing. So to start with the classical and quantum physics, the dynamical state of a system in classical mechanics can be ascertained if we have the information about the position and momentum of all the particles, and at any given instance t, obviously, and the interaction in them t, which is responsible for evolution of the system. Now, for that, if you have a single particle, you need to know what is the position of the particle and velocity of the particle at some time t is equal to t0, and at the same time forces acting on the particle, so that you can just solve Newton's second law of motion and then predict what is the future motion of the particle. Such a maximum information is not available in quantum physics due to the restrictions imposed by Heisenberg's uncertainty principle, which says that we cannot simultaneously precisely measure variables which are conjugate variables, and considering that x and p are conjugate variables, it is impossible to measure precisely both these quantities, and that is how there was a need to define a new theory which came in 1925 from Heisenberg and 1926 from Schrodinger. So we'll not get into the detail of the equations, but I would just like to comment a little bit on transition from classical to quantum physics. So there was a time when people thought that classical mechanics is the ultimate theory, and any challenge that could be thrown to the physicist can be tackled by classical theory. But black body radiation, photoelectric effect, and enormous amount of data which was present in terms of atomic spectra forced people to think that there is something more that is required to be proposed rather than a classical theory. That doesn't mean that classical theory is wrong. It only says that it is not applicable to subatomic particles. So that was, I think, very emotional phase for most of the physicists when Planck proposed his hypothesis of quantization of energy, and which was also borrowed by Einstein to explain the photoelectric effect. Niels Bohr, he kind of deviated a little bit and said that angular momentum is quantized, and he proposed the model for atomic structure, which was also found to be correct only for single electron system, and when it was applied to 2 electron system and so on, it was not perfectly reproduced in experiments. So in fact, Schrodinger, from yesterday, we are listening many quotes like Damdul also said God doesn't play dice, or Niels Bohr said that if you're not shocked by quantum mechanics, you actually don't understand it. So Schrodinger, he got so much emotional from all these arguments that were going on. He in fact said that if this entanglement thing is supposed to be correct or proved to be correct one day, I'm sorry that I have contributed towards it. So I'll talk about one experiment which was happening in 1922, around 1922. This is called Stern-Gerlach experiment, and which played a major role in establishing the quantization in quantum theory. And the article says how a bad cigar helped reorient quantum physics. So if you get a time, please read this article. It's a beautiful article. So there was this scientist Stern, who was a physical chemist and working with Max Born. So he wanted to prove that angular momentum is quantized. And for that, he actually collaborated with another physicist who was Gerlach, and Gerlach was an expert in molecular beam experiments. So they both went to Max Born because it was kind of an era where because of World War I and all, the funding was very less. So they went to Max Born and they convinced him to give lectures on quantum physics so that they can collect a lot, some money so that they can start their experiments, and that's how they started doing this experiment. So the experiment actually, there was an oven where Ag atoms were there and they were vaporized so that the electrons were coming in this direction, and then you have a magnet. So this magnet represents actually a non-homogeneous magnetic field, and electrons, considering that it is revolving either in clockwise or anti-clockwise direction, the magnetic field actually exerts a force and takes them into 2 different directions. So they were expecting that if angular momentum or dipole moment is quantized, that they should have 2 such spots on the photographic plate. But unfortunately, their experiment failed. They repeated it many times, but every time it failed. Meanwhile, Stern moved from Frankfurt to Gutenberg, and Gerlach seemed to meet him one day in his lab, and then he had to come back. So the morning he went to catch the train, he missed his train, and he had to go back again to Stern's lab, and they repeated the experiment, and it failed again. So that's very frustrating. But then what happened was Stern was looking at the photographic plate, and he was a chain smoker, and he used to smoke bad cigars in the sense it was cheap cigar which was high in sulfur content. So he was smoking, and the smoke was hitting the photographic plate. The photographic plate had Ag, so Ag interacted or reacted with sulfur, and Ag2s precipitated, and they saw the 2 black spots. And that is how this whole story of how a bad cigar helped reorient quantum physics. But the moral of the story still remains the same, that smoking is injurious to health. So please, let's go ahead. Yesterday, superposition principle was talked about, and just giving a small experiment where there is a there is a light source, and there are three filters: filter A, filter B, and filter C. Filter A is polarized in horizontal direction, filter C is polarized in vertical direction, and filter B is polarized somewhere in the middle of horizontal and vertical direction, like this. So this light source, you put the light source, when you put the filter A, it is found that half of the intensity reaches to the screen. Now that is only possible if the incoming photons or electrons are arbitrarily polarized in any direction. If this was only allowing those photons to pass through which were horizontally polarized, then intensity would not be half of the initial intensity. Then if you put a filter C which is vertically polarized, it blocks all the horizontally polarized photons, which is understandable because there is no projection of horizontal in vertical direction. Then you put a filter B which is polarized somewhere in between, and you get 1/8 of the intensity which was started at the beginning. Now this whole phenomena can only be explained on the basis of assuming that the superposition principle, that the photons are polarized in an arbitrary linear superposition of horizontal and vertical polarization. So with this, I'll just move forward to tell you one simple example where this how do this superposition can help, or quantum strategies can help you in a simple game. Say for example, if I talk about this game, there are two players, player P and player Q, and the condition of this game is like player P has a coin which is heads up. He gives this coin heads up to Q. Q has a choice either to flip this coin or not flip this coin. Then he returns it back to P. P again has choice either to flip the coin or not flip the coin. And then finally he gives it to Q, who again have the choice either to flip the coin or not flip the coin. Finally, if they open the box, they cannot see what is happening. They can only flip or choose not to flip. But finally, when they open the box, if it is heads up, then Q wins the game, and if it is tails up, then P wins the game. Classically, if you look at it, like I have shown it here with a payoff matrix, we don't want to go into detail of that, but classically it is 50% probability that P can win the game and 50% probability that Q can win the game. Now let's modify this game into quantum regime and say that one of them is a classical player and one of them is a quantum player. That means the quantum player can use the strategies that are allowed by quantum mechanics. So what happens in this case is, player P, when he gives a coin which is heads up to Q, he performs a unitary operation on this and changes head to head plus del by root 2. Now when P comes, he has a choice either to flip or not flip the coin. So if he flips the coin, H goes to T and T goes to H, and the state remains the same. If it doesn't flips the coin, state still remains the same. So H plus T by root 2, irrespective of what P does, remains H plus T by root 2. Then Q comes again and he again applies the same unitary transformation and changes it to H. So irrespective of what P does, Q always wins again. And that was only because he was employing a quantum strategy. Does that mean that quantum strategies are always helpful in winning a game? No. This is a particular situation which I have shown you where quantum strategies could be useful. Now moving forward, we were talking about, I just want to talk about how do we represent this system. So a two-level classical system, you can take an analogy where you have a coin. So if you toss the coin, in general you only get a head or a tail. However, a quantum system can also be represented as a head or a tail. I'm just putting it in a bracket to show that these are quantum states. So these can be represented, and in the superposition principle we have also seen that these can be represented, this set can also be represented as linear superposition of H and T, where the absolute square of A is absolute square of A and absolute square of B represent the probability that how many times you are going to get H and how many times you are going to get T, and the probability has to sum up to 1, and that is why the condition shows that absolute square of A and absolute square of B, when you sum them, it becomes 1. So that's the representation when we talk about classical or a quantum two-level system. And if you increase the number of systems, if you have 2 coins, if you get a head here and a head here, you have a head. If you get a head here and tail here, head tail, tail head and tail. So you have 4 possibilities for a 2 coins if you're dealing with 2 coins. However, if you take 2 particle system, which is you want to represent in quantum mechanics, then it can be represented as linear superposition of all these possible states, and this is what sometimes gives rise to what is called as quantum parallelism, which is responsible for the speed of quantum computing. So yesterday, Professor Ujjwal Sen, he talked about quantum entanglement, where he was telling that if you are writing the state of 2 particle system and if you can factorize it, right? He was using A and B, and he said that if you could factorize it, then that is not entangled, and if you cannot factorize the state, then they are entangled. What he actually meant, and he explained that it is like individuality of those photons. If we can have the individuality is inherent in the system, then that is not an entangled state, otherwise it is an entangled state. Say for example, if we take the linear superposition here, we have taken a linear position of HH, superposition of HH, ST, TH and TT. This can be actually written as H plus T for first coin and H plus T for the second coin. So you can actually factorize this, and hence it is not entangled. Whereas the other cases, there are some Bell states, other superpositions which give you entanglement, and I'm just taking a cue of from yesterday's presentation of Professor Saji and Professor Ujjwal Sen, where they did talk about smiling face and sad face, and then pink flower and blue flower, and so on, to explain this phenomena. So moving forward, because we have to also discuss a little bit more about substance and form, where I have to take the example of quantum teleportation. No cloning theorem is something that tells us that quantum states cannot be cloned. So with this we come to the teleportation. So teleportation, I hope many of you would have either heard about it, or you would have seen it in science fiction serials or movies. In fact, I remember a few months back I was giving a presentation in IT Roorkee, and I was just working on the presentation in the hotel, and my son was also there. He's a 6-year-old kid. So he came to me and he just teleportation was mentioned somewhere in between. It was not a general talk, but something related to my work. And he just came and he said, "Okay, I know this. So you are talking about teleportation." I said, "How do you know about teleportation?" So I said, did you see it in some movie, anything? He said, no. See, few days back I saw that Doraemon teleported Nobita to Shizuka's house. So it's kind of a message that everybody knows one way or the other way what teleportation is. So teleportation as such is a process in which the state of an object is teleported from one orbit location to another orbit location without sending it through a medium, or without making any measurement on either side of the protocol. So these were the brilliant minds which should be congratulated for this science fiction to be put on paper in reality. In 1993 they published this paper, which came in Physical Review Letters, teleporting an unknown quantum state via dual classical Einstein-Podolsky-Rosen channels. And then the first experiment came in 1997 from Baumeister and Aston Dillinger's lab. So now, what is it that we are teleporting? Are we teleporting the substance, that means the particle itself, or are we teleporting the form of it? In fact, we are actually teleporting the form of it and not the substance as such. Because when you teleport, the particle remains where it was. It was its state which is teleported from one place to another. So, is that bad? No, not exactly, because what is happening is you are actually sending all the information about your system which is inherent and which you need to reproduce that state on the other side. So this was the basic experimental setup. You can see here that the EPR shows it generates an entangled pair, and then it goes towards Alice, and Alice also has an initial state which is unknown to her also. She does some two particle measurement that we do not have to worry about here. Then she sends a classical message to Bob about her measurement outcome. Based on her measurement outcome, he applies a unitary transformation and retrieves the teleported state. So this is another representation of the actual representation actually. So then comes the question, is teleportation same as quantum facts? It is not, because in teleportation we are only sending limited amount of information, and teleportation we are sending a quantum state which has infinite amount of data. And also when you send a fax, the other person can intervene in between and see what the information is, whereas the same cannot be done in quantum teleportation. That is why it is kind of, there is no medium, right? The information, thank you. The information is sent instantaneously from one place to another rather than sending it through a medium. So there is no threat of somebody eavesdropping in between. So in that sense, it is very secure. So can we teleport bigger objects? As far as technology is concerned, no, not right now. But then we also have instance that the Buddha with many of his followers did cross Ganga river with the blink of an eye. There's a story. So maybe there is something much more for us to probably understand and look into. That's why probably such conferences may help in synergizing different concepts to learn more about quantum entanglement and non-locality. So thank you. With this, I'll stop. Thank you very much.
Thank you, Dr. Atul, for your nice presentation. You have presented your paper on substance, form, and their interaction, just like Dr. Prasoon Roy did, but your area was different. He spoke from the standpoint of neuroscience, you from standpoint of quantum physics. And you started with the great philosopher Aristotle and then proceeded from classical physics to quantum physics, and you explained very nicely your work with different experiments showing with examples of quantum advantages, and I think the best one is this teleportation. With these few words, I congratulate you again for this nice presentation, and I think he deserves a special applaud for his presentation. Our third speaker is Miss Pooja Dabral. She is an assistant professor, Department of Buddhist and Tibetan Studies at Namgyal Institute of Tibetology, Gangtok, Sikkim. Her doctoral research topic is Nagarjuna's philosophy of emptiness and J. Tsongkhapa's exposition, Descent in Two Prolific Periods. She has teaching and research experience with a range of institutions, including the University of Delhi, Jawaharlal Nehru University, Tibet House, and YMCA. Pooja has numerous publications and has also presented papers on the themes such as the practice of emptiness, Anatman, a Buddhist approach to inner and world peace, Buddhist psychology, form and substance in Buddhist philosophy, and so forth at national and international conferences and seminars. So with these few words, I welcome Pooja to present her paper.
Hello everyone, and I thank the chair for kind introduction of mine, and I want to thank again the organizers for this invitation to this conference. One thing which is so interesting about the conference is that every speaker is trying to make things to explain the very unique points of their subject in a very simple possible words. So thank you very much indeed for that. And because I just said that, so I'll try to make things simple for you as well. So now the topic I'm given to talk on is the substance, form and interaction in Buddhist philosophy. And sorry. Okay, so the topic is substance, form and interaction in Buddhist philosophy. So in very loose sense, in general terms, substance has the connotation of something from the object in very loose sense. Details will follow. But before I go into the details, let me share with you the citations from Buddha's Sutra, which are the Buddha's words, about the forms, about the nature of the form and the substance. So this comes from the Upali requested sutra, in Sanskrit Upali Pati Parishana Nama Mahayana Sutra. So in that sutra, Buddha said, various delightful flowers blossom, and the sparkling supreme golden abode stands so alluring. For none of these is there a creator. They are posited by the power of thought. It is through conceptualization that the world is imputed. And then in Dhammapad, which is the collection of Buddha's Sutra in verse form, Buddha says, all forms are unreal. He who knows and sees becomes passive in pain. This is the way that leads to purity. So now, do we get, after reading this, do we get the impression that forms are unreal, basically non-existent because they are mentally imputed? If we get this impression, then rest part of my paper does not make any sense. So here comes the need to make the distinction, which many speakers presented yesterday also, and I also touched upon, the two realities of every phenomena, which we call in Buddhist terminologies or the philosophical paradigm, the conventional reality and the objective reality. So when it comes to the objective reality, for example, yesterday Venerable Geshe-la, and then I also touched upon the example of water. When you look at it through the naked eyes, you see it in the form of a liquid or water. And when you see it through electron microscope, you just see the bunch of molecules. And none of the perception is wrong. Both are the realities and both the correct realities. But then the question is asked, when the question is asked, what is the objective reality where there is no or where there is no involvement of the subjective mind, then Buddha is saying that there is no objective reality of the object. It makes sense only in the reality of the object, or identity of the object makes sense only in dependence on the subjective mind. In dependence on the frame of reference, the things make sense. So that's why it is said that it is through conceptualization that the world is imputed. It is not being said that the world is empty means world is non-existent. There is a huge difference when we say things are empty of objective existence and things are non-existence. There is no, so there is a huge difference which we need to study more. Okay, so now I'll move on to the topic. So the substance, as I said earlier, substance has a, in very loose sense, we say substance has the connotation of something, and it is not, I think personally, it is not only in the philosophical world, everywhere. The substance has the connotation of something from the object as opposed to subject. Whenever we talk about substance or somebody talks about subject in any discipline, the thought we have is something from the object. We never think about substance from the mind or from the subject. So in very loose sense, subject has the connotation of something from the object. Now in Buddhist philosophy, we have 4 Buddhist philosophical schools by the name Vaibhashika, Sautantrika, Chittamatra or Yogacara, and the Madhyamika schools, and they are progressively subtler in progressively higher. Why higher? Because they progressively present the subtler ontological reality of the object. So this question that what is the ontological reality of the object, where there is no involvement of the subjective mind, so they present differently, and it is the Madhyamika is the highest Buddhist school because it presents the subtlest of the ontological reality. So I'll go to them one by one. Okay, so now in the Buddhist paradigm, in the Buddhist philosophical system, anything that exists is called phenomena. So existence and phenomena, they are synonymous. And then anything that exists is further classified into 2. The broad categories are composite phenomena and the non-composite phenomena. The composite phenomena and the impermanent phenomena, impermanent things are synonymous, and the non-composite phenomena and the permanent things are synonymous. Then the composite phenomena are further classified into 3, which are physical form or matter. Then second is mind, and third is non-associated composite factors. So my presentation of today's hovers around the first category, which is form. And then form includes everything physical that we experience. For example, the objects of our 5 sensory consciousness, visual objects, smell, sound, taste, and tactile objects. Then the 5 sensory mediums through which our 5 sensory consciousness, they interact with these 5 objects. For example, the eye sense power, nose sense power, ear sense power, they fall under this category of form. And then also 4 great elements which will come later are also part of this form category. And then the next category is the mind, where includes all the sensory and the mental consciousness, and all the mental factors such as happiness and then compassion. All these fall under this second category of mind. And then next is, and third category is very interesting, which is non-associated composite factors. Sounds very technical, but it is very simple that anything which is impermanent and not a form and not a mind falls under this category. For example, self, time, and many other phenomena. Okay, so now I'll go to the technical definition of the form, which is something consisting of atomically composed things. So the word here, atom, please, it should not be understood in the context of the physics, the way atom is described in physics. Here it simply means particle. So anything which is consisting of partically composed things is known as form in philosophical paradigm. Okay, next is, sorry. So now I go to the presentation of the 4 different schools. Substance, okay. So first I'll talk about the Vaibhashika and the Sautantrika school, which are the lower Buddhist school, lower for no other reason, as I mentioned earlier also, because the reality, the ontological reality of the object they present is grosser than the other 2 schools. Okay, so Vaibhashika and Sautantrika, they have a very interesting presentation of known as partless particle. So this citation comes from Acharya Vasubandhu's text known as Abhidharma Kosh. So this says that a partless particle, a syllable, and a single moment are the smallest unit of matter, of words, and of the time. So what is being said here is that they accept that all the physical matter, form, anything physical we experience is actually composed of this partless particle. The smallest unit of the physical matter is this partless particle. Partless particle means which does not have any parts. Okay, and what are the characteristics and what are the features of this partless particle? So some features are here, that it is very fine and it is the finest or the smallest constituent of the matter. It has no spatial dimension, and then it never exists on its own. It always exists in combination of the other particles. And the last is that every subtle particle, every partless particle is composed of at least 8 substances. And what are these 8 substances called? So the 4 great elements: the element of earth, element of water, element of fire, and element of wind. And then the 4 elements derivative forms is smell, taste, and tangibility. So this great element, just to give you a little detail, this Mahabhutas, or the great elements, which actually has 2 words, great and elements. Why are they called so? Because they are great in that they are found in all the matter, and they are elements, or the bhutas, because they are the ultimate constituents of everything within the physical world. So now you can see this table. So the table, the second column presents the essential nature of these elements, such as the earth element. The essential nature is the solidity, and its function is the solidification or supporting. And then the water element, the essential nature is the moistness, and the function is gluing, binding. And then the fire element, the essential nature is warmth, and the function is in the form of ripening or maturing. So in short, every particle accepted in the philosophical paradigm should have should be composed of these 4 great elements, having the potentiality of solidification because of the earth element, then having the potentiality of binding or gluing because of the water element in it, and then having the potentiality of maturing or ripening because of the fire element, and then likewise mobility because of the wind element. And then there are 4 derivative elements too. So every subtle particle should be composed of the 8 substances, and these 8 substances, when I say these 8 elements, so we get the impression of that as if they are very physical and solid in nature. So we have to think about the qualities. So every subtle particle which is partless in nature is composed of 8 substances, and these 8 substances are in the form of the potentiality or the qualities of that particle. Okay, so next I go to... Okay, this is something interesting. So now from this subtlest particle, which is known as the partless particle, when the question is asked, how does the macroscopic world, the massive objects, they emerge, then in many sutras and then later commentaries, what is known as the principle of atomic agglomeration is presented. For example, and there are different systems and different systems within the principle of this. So for example, one of the system of atomic agglomeration is presented in extensive display sutra and Abhidharma Kosh, which increases by the 7-fold increment. So I won't go into the details. So basically, how the massive or the macroscopic world come into being or emerges from the subtle particles is explained on the basis of the principle of atomic agglomeration. And for your information, this is not the only principle. There are different, for example, in Vinaya Sutras, there is a mention of atomic agglomeration, which increases by the factor of 6. And then what is interesting here in these texts, if you read these texts, especially Abhidharma Kosh, depending on these agglomeration principles, there is a mention of the specification on the size of the one sun ray particle, then dust particle, then hair of the rabbit, and then smoke particles. So this could be very interesting to read. Okay, next is, now I go to the higher Buddhist schools, which are Chittamatra and Madhyamika. So what is interesting to know here is that the lower schools, where Bharshika and Sautantrika, they present partless particle. And the Chittamatra and Madhyamika school, they reject partless particles. They are the major critique of this partless particle. So how they reject it? It comes from the Acharya Vasubandhu's text. Actually, this This explanation comes from many other texts, but here a very well-known formulation comes from Acharya Vasubandhu's text known as 20 stanzas, where he refutes through the valid reasoning this existence of the partless particle, and I have to go through it very fast. So first I'll read the verse. So he says that because of being simultaneously surrounded by the 6 other particles, the central subtle particle is found to have 6 parts. If these 6 parts have the same spatial dimension, a massive object will conflate into the size of just a minute particle. So what is being rejected? So what he is arguing is that however minute a particle is, whether you call about a partless particle, subtlest particle, most refined particle, it should have parts. This is the argument. And how does it prove it? So this diagram is nowhere in the sutras or in any text. It just, I picked them from the Google to make things easier for us. Okay, so what he's saying, I'll just give you one example. For example, this water bottle, it is composed of millions of particles. And the lower schools and the higher schools both will agree with it. So now when it composed of millions of particles, so Acharya Vasubandhu is telling them that from this pool of the particles, you just pick up any particle. Picking up does not mean you physically pick it up, but you just mark it as a central particle. And how central? Because it is surrounded by the 6 other particles. 6 other particles, how? 4 particles in the 4 cardinal directions, north, south, east and west, and then 1 above and 1 below. And then he's saying when you pick up this, which is the central particle, you mark the central particle, and since it is surrounded by the 6 particles, it is a proof that the central particle has 6 parts within. So now it should not be that easy to prove. So what now the lower schools, they argue that, okay, we agree that every central particle is surrounded by some other particles, but that does not prove that the central particle has 6 parts within. Then he goes on, so he gives further logical reasoning to prove it. How he proves is that, for example, he says, okay, let's say, let's say this is the central particle we have marked. This is the orange particle, and it is further, okay, let's take this example, this diagram. So this orange particle is surrounded by the 6 particles, and then what he's saying, if I accept your position that the central particle does not have any part, then you are forced to accept that the particle in the north, and the particle in the south, the particle in the north which touches the part of the central particle should also be touched by the particle in the south, because the central particle you are saying is partless. So they too should touch the same part of the central particle. If they touch the same side of the central particle, in a way you are saying that the particle in the north and the particle in the south, they two will meet. If they two will meet, then the central particle should disappear. And if central particle disappears, then, and likewise if you take other particles as a central particle, and then likewise because of your own reasoning, he flings the consequence. If you accept the central particles to not to have any part which touches the north and a separate part which touches the south, in a way you have to accept that both the particles which touch the same side. If both the particles, now north particle and south particle, touch the same side, then the central particle disappears. Does not make any sense. So the two particles, particle in the north and the particle in the south, will conflate, and likewise all other particles will keep on conflating. So now in the last line in the last line he is arguing that how will you account for a massive object? He says that, you know, we see the difference in a bottle and a small particle because of the size. But then if I accept what you're saying, that the partless particle is a particle which does not have a part, then the surrounding particles will keep on conflating. If they keep on conflating, then how do we account for the massive objects? Then you cannot account for the macroscopic world. So this is the contradiction, and this is how he rejects the position of partless particle. And now here we need to make, okay, so one thing which we need to note here is the difference between the partless particle versus indivisible particle. Okay, good. So indivisible particle, as we talk about in physics, the quarks is accepted to be the indivisible particle at the moment, but there is a difference. So while we accept in Buddhist philosophy the partless particle, it is not necessary that we are rejecting the indivisible particle. What Acharya Vasubandhu is saying, however minute a particulate, whether you call it an indivisible particle, you may not, because you call it an indivisible particle because you cannot physically divide into parts, but mentally and logically you can always divide into parts. So while you accept the individual particle, while you reject the partless particle, you can accept the individual particle too, as accepted in science. Okay, next I'll go to the higher Buddhist schools. Because of constraint of time, I'll directly jump to the Prasangika Madhyamika school, the highest of this highest of the Buddhist school. Okay, so what Prasangika Madhyamika's philosophy is, that the central philosophy of Prasangika Madhyamika is that nothing exists objectively. That we learned that there is no, what is the ontological reality of the object? That they do not have any objective existence. It is sheer independence on the mental imputation or the subjective mind that the things make sense, as example given of the water and water. Now, that does not mean, as I mentioned earlier also, that when things exist from independence of the subjective mind, they are non-existent. There is a huge difference. When things existing from the independence of the subjective mind is a fact, and things do not existing from ontological reality, the other version is the other version of the same fact. So what they are saying is that the things do not exist objectively, and one very unique thing they say is they equate the substance. This is something very different of Prasangika Madhyamika. They equate the substance, as I mentioned in the beginning of my talk, that most of the time when we talk about the substance, the thought comes to our mind is something from the object. So now what is so unique of the Prasangika Madhyamika philosophy is that they equate the substance, of course, as we equate the substance with the object, something from the object, and therefore, since they reject existence from the object, they reject the substance. This is something unique of this school, but that does not mean that they reject the empirical world of particles. They accept that the particles do exist, they have a mass, charge, everything, but they themselves do not have any objective reality. When you analyze actually these particles too, you will find out they further have parts, and therefore they do not have any objective reality. They are also existent in dependence on the subjective mind. So this is something unique of Prasangika Madhyamika school. So now, so they accept particles, they accept the physical world, form, everything, but they do not accept them, the form, the subtlest of the particle even, and the massive object like mountains to have any objective existence. They exist by sheer dependence on the subjective mind. Okay, so now next is a very interesting concept of space particle, and this is something coming from the Indian Tantrayana system of Shri Kalachakra Tantra, but I won't go into the detail. The unique thing is that these space particles are explained to be responsible for the emergence of the world system in repeated cycles. Sometimes this is a confusion how world system emerge after destruction of a world system. So this space particle is a very good explanation for that question. So I won't go into the detail. Now last, as I summarize my paper, so I would like to make 3 points. That now from this presentation, what I want to share is that the substance has different connotation. One connotation is the substance in terms of something constituted of the particles, which is fairly accepted by almost all the Buddhist schools. Then second is the substance in the form of something as external to the perceiving mind. This I could not go through, means I could not present here because of the constraint of time, but this is coming from the Chittamatra philosophy, whose central philosophy is that everything is the nature of the mind. Nothing exists external to the mind. So when some substance is thought about something as external to the mind, they reject it. They don't accept it. And the last is the subtlest understanding of the substance, which comes from the Prasangika Madhyamika school in terms of objectivity as opposed to subjectivity. So Prasangika Madhyamika does not accept this connotation of the subject, that's of the substance means something from the object. Thank you. Thank you for your attention.
Thank you, Pooja, for your nice exposition. You have very, very elaborately and presented the Buddhist view very well, and it is well documented with adequate quotations from text, and you have tried to link it up with Google pictures and so on. Now you started with the very interesting Upali Poripricha Sutra and then Dhammapada to show that form is something unreal. But as you proceeded, you tried to unfold the different dimensions of Buddhist philosophy to show that form is not something unreal. But you also explained if form is regarded as something real, then it would be inconsistent with their notion of anityata, because then the question will arise whether that form is something over and above the substance, whether it is eternal or not. These questions will arise, and you have very, very nicely addressed all those questions and tried to explain what the different schools of Buddhism would have said about the notion of substance and the notion of form. So the interesting feature of this session is that all the three papers were concentrated on one particular theme, and perhaps the organizers of the conference have done it intentionally to present the notion of substance and form, how the notion of substance and form can be looked at from three different perspectives: one from the perspective of neuroscience, one from the perspective of physics, and another from the perspective of Buddhist philosophy. And all the three speakers, they are experts in their own fields, and they have done their jobs very, very successfully. And I must congratulate all of them for their immense task. And I think that all of them should need a great applaud from you. So now is the time for question and answer. We can have 10 minutes time. 10 minutes time. It's okay. So 1-5. So how many questions can we ask? I have seen two hands. No, okay. Let me ask. Yes.
For Dr. Kumar, thank you for your presentation. I wonder if you'd say a word about the collapse of the wave function. For a wave function that's a particles in superposition to collapse to a specific state, does that require consciousness or not, and why or why not?
That requires what?
For a particle that's in a superposition to collapse the wave function to a specific locality,
Right.
does that require a conscious observer, or can there be some other factor that causes that superposition to collapse?
Okay, it can be both actually. So, say for example, if I'm asking a question that which state you are in, it can collapse and tell me which state it is in. At the same time, even if I'm not asking a question, then also it may happen that it interacts with say magnetic field or electric field and modifies to some different state, which may not be a pure state. It could probably evolve into a mixed state. So this possibility is also there. But the moment you ask a question that which state you are in, one thing is certain, that the wave function will collapse to one of the possible possibilities, right? So say for example, I just want to give you this analogy of coin that I was just talking about it, right? Once the coin is in my hand, I don't know what is the state of this coin. It could be head, it could be tail, it could be anything in between head and tail. It can be any linear superposition of head and tail. But the moment I constitute a measurement, that is when I toss this coin, that is a measurement, then I get either a head or a tail. So just before the measurement, the coin itself doesn't know whether it is a head or a tail, because it is kind of flip-flopping between head and tail. If I'm talking about a quantum coin. So if you are talking about a spin in a kind of a superposition state, it may not be knowing exactly that whether it is spin up or spin down. That is what happens, that it keeps flip-flopping between up and down. But the moment you ask a question, you get your answer whether it is spin up or spin down.
But also in your example, you gave of the coin, but there is no quantum coin, is there? I mean, isn't that impossible?
Yeah.
Is it impossible for an actual coin to be in a quantum
It's just
state?
an analogy that we are taking in classical physics, that say for example, if you are looking into the classical world, then the example could be given as a coin which has only two possible states, whereas when you are looking at in a quantum world, it can have those two states, but at the same time, say for example, if you toss the coin, it can stand up, right? It may not give you a head or a tail. If it stands up, then we say that there is a 50% probability that you still get a head, and there is a 50% probability that you still get a tail. So that means you can represent it as a linear superposition of head and tail. Now you think about that between head and tail, if you rotate this coin by a very small angle, that is still a possibility with a different probability of getting a head and tail and so on. So there are infinite such angles or positions you can find and define your state. Then that is why you say that it's an arbitrary linear combination, A head plus B tail, or A0 plus B1, or A up plus B down. So when I represented it, I have shown it with head just to take an analogy, so that people should be, because it's a general audience, so people should be able to see what is happening. Or say for example, yesterday when there were other talks, we talked about a sad face or a happy face, or a pink flower or a blue flower and so on.
You spoke about teleportation. So one object can be estimated to be this, but this it cannot be yeah. It cannot be, there can be no intervention between, there's no medium at all. If there's no medium, how do you explain this?
Yes, that is why we are saying that it is the form that has been teleported and not the substance. When you are saying that substance is teleported, you are saying that the mass or the energy has been teleported, which requires a medium. But when you are saying that you have only teleported the state, that means you are only sending some information from one place to another, and that too, what you are doing, actually you are doing a measurement here such that the two entangled particles, which kind of act as a medium, correlations between those two particles, that correlation is broken and a new correlation is developed between first two particles, and it is, the measurement is done in a way that the state which was here goes to the third particle rather than sending it through a medium. So you can, the one example that is given in which we talk about is, say for example, on one side you have a clay model. So on one side you can have a clay model, on this side you can have a clay toy, actually which have a defined shape, and the other side you only have a pile of clay. But the moment you do the teleportation, what happens, this clay which was having a defined shape here distorts, goes into some other shape, it has to lose this shape, and whatever the original shape was there, that the other pile of clay takes that shape. So that is what happens.
It was only the shape, not the substance.
It's not the substance, not the substance at all. That is why when we talk about human teleportation, I'm saying that it is not possible, because
I can allow only one question. Please, the second and the third, from the third.
So this can go to either Dr. Kumar or Pujala. So when you are describing Vasubandhu's reasoning there, if you then maybe combining the two subjects of when the physics perspective of superposition, it seems like on the surface level that's rejecting superposition. If you take superposition to literally mean two substantial entities occupying one place, right? Because they would then conflate two point particles occupying one place. So then, does this imply, if you take this logical reasoning to be valid, would it then imply that the superposition has to simply be an epistemological or mathematical framework as opposed to a substantial, objective substance of the particle?
I think you can answer first because I'm not competent to answer the superposition part. But as per Acharya Vasubandhu's philosophy, I would say, the substance has a connotation which occupies some space. So if we go by that, and if in superposition, I think better would be I listen to him first and then say something.
Can you just repeat it again? In a superposition. Yeah. Also,
Please, we have to back it up.
so I would say that it is true in theory. What you are saying is it correct as mathematical representations? Yes, but is it only mathematical representation? No, because experimentally also it has been shown that superposition do exist. I did give you one example, a simple example where you had a light source and you had different polarization filters, and the only way we could explain it using the superposition principle, that means the particles do exist in a superposition state. Now, when you are talking about analogy, right, that can we take?
This is a logical reasoning that you have two particles that are both partless, point particles, then they would conflate into only one space, and you wouldn't be able to ever have a gross agglomeration of those particles.
Okay, so basically for this, the response is that when we talk about a superposition, we're talking about one object behaving in two different ways. Now listen, the cat, whether it's dead or not, the cat is one object, and then the two descriptions, the two behaviors. So whether it is here or there, dead or alive, is referring to the same object. What Buddha is referring is two different objects. Two different objects, whether they touch or not touch. So this distinction you have to make.
So I think that there are lots of questions among you, and which I couldn't allow you to, because of the shortage of time. So I with these few words, I want to conclude this session. But before that, I must thank the two speakers and the other participants for this nice session. Thank you all.
Thank you, Honorable Chair, for these spectacular presentations. Thank you very much for that. I now request the Honorable Chairperson, Professor Chattopadhyay, to kindly felicitate the Honorable Speakers here. Thank you. Lunch for the speakers. Lunch is arranged in the Annexure building for all the speakers, the first floor. For the audience, just as yesterday, the lunch is arranged outside this hall. Thank you. Thank you very much. And we meet at 2 p.m.